Hello, I'm Pascal. After I gave you what the mathematical induction it is, I will give you some example of it. And in this video, I just give you three of them. I mean the examples of mathematical induction. Look at here. These three exercises will make you to be clearer and clearer in induction. Yeah, and as I told you, in mathematical induction, I mean mathematical or mathematical induction is very important. Yeah, it can solve many problems as well as exercises. Yeah, let's see together the three exercise. 1, 2, 3. Yeah, and 1. The first exercise, if A1, A2 until AN are arbitrary real numbers, show that the absolute values of A1 plus A2 plus until AN is less than or equal to the absolute value of A1 plus the absolute value of A2 plus blah 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 blah, I mean until the absolute value of AN. Here N is a natural number. Okay, N is natural number. And maybe all of you are familiar with this inequality. Yeah. If we just omit a part of this, I just take two of them, A1, A2. So you will get A1 plus A2, the absolute value of it less than or equal to A1 plus A2. Yeah. The absolute value of A1 plus A2 less than or equal to the absolute value of A1 plus the absolute value of A2, right? And this one, we call it the triangle inequality, right? In this, maybe it is more general, more general than triangle inequality. It's not only two terms. You have like n term in the absolute value, okay? Okay, let's see together what the proofs of it. Yeah, exercise 1. And as I told you, I will give you the answer of this by using mathematical induction, or we can say mathematical induction, right? And let's see together. And by the induction, we have to check for any n, n equal to 1 or equal to 2, right? In fact, we can say if n equal to 1, then you get what? In fact, A1, the absolute value of it equal to the absolute value of A1, right? Yeah. And from this, you can get the absolute value of A1 less than or equal to the absolute value of A1. Yeah. It is true. True for n equal to 1. Yeah. Why? Maybe some of you understand about this one. When we get the absolute value of A1 equal to the absolute of A1, this is true, right? And why did we get this one? If this is true, why do we get this one? Yeah. Because this one we use or conjunction. Less than or equal. So for the or conjunction, if 1 is true, the or conjunction is true. I mean that if at least one proportion among proportion in or conjunction is true, the or conjunction is true also. This one is true. Less than or equal. In fact, it's not less than, it's equal, right? So equal is true, so less than or equal also is true. and this is true, it means that it's true for n equal to 1. And now we suppose, suppose that it is true for n equal to 1, equal to k. Yeah. It means that is a1 plus a2 plus blah blah until an, ak, right? Less than or equal to what? The absolute value of a1 plus a2 plus blah 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 until the absolute value of ak. Yeah. Suppose that it is true for n equal to k, it means that this is true. Yeah, this is true. So we will show that it is true for n equal to k plus 1 also. If we suppose that it is true for n equal to k, we will show you that it is true also for n equal to k plus 1. And if it is true for n equal to k plus 1, it means that it is true for general. This is because of mathematical induction. Did you get it? Okay, so now we have, I will show that it is true for n equal to k plus 1. We have a1 plus a2 blah 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 until ak plus ak plus 1. The absolute value of this one, we have this one. We can, in fact, we can get like this. We can associate the term from 1 to k, so you get this one equal to the absolute value of a1 plus a2 blah blah blah, blah until ak, right? We associate the k term, the first k term of this, so you get this one a1 a2 until ak, and then plus this one ak plus 1. Yeah, cool, right? We just associate the first k term. And from this, you can use what? Triangle inequality. I mean, for the triangle inequality, we have only two terms. We suppose this one equal to A and this one equal to B, right? And then by the triangle inequality, you get this equal to 1, less than equal to, the absolute value of A1 plus A2 plus blah blah until AK, right? And this one plus the absolute value of what? AK plus 1, AK plus 1. Yeah. And since this inequality is true for n equal to k, so the absolute value of a1 plus a2 plus blah 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 until ak is less than equal to 1, less than equal to a1, a2, ak. So this one you can say less than equal to the absolute value of a1 plus the absolute value of a2 plus blah 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 until the absolute value of ak, right? Because of this one, it is true for n equal to k, you get like this. So this one, the last term is what? Ak plus 1, right? And this is something that we want, right? So at the end we get this. Yeah. So we get a1, the absolute of a1 plus a2 blah 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 until ak plus 1, right? The absolute of this less than what? The last one, I mean the last step that we get, a1 plus a2 plus the absolute value of what? ak plus 1. Yeah. So this, it means that is, it is true for n equal to k plus 1, right? And by induction, by mathematical induction, this is true for all n equal to, for all n is a natural number. So we can, by induction, a1 plus a2 plus blah 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 until an less than or equal to the absolute value of a1 plus the absolute value of a2 plus blah 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 until the absolute value of an. For all n belong to capital N. N is a natural number, right? Yeah. This is the solution of the first exercise that we use mathematical or mathematical induction to show it or to prove it. Yeah. And for the second one, the second exercise, you see this one? Given you that ai is greater than or equal to 0 for I belong to n and I is greater than or equal to 1. Yeah. Show that 1 plus is 1 multiplied by 1 plus is 2 multiply blah 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 until 1 plus ai. Yeah. And this you will get it's greater than or equal to 1 plus is 1 plus is 2 blah 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 until plus ai. Yeah. And we will use mathematical induction to show this also. Yeah. So let me omit this one to write the answer, right? I will take this exercise here. I will not omit it. I will try to show you that this is true. Okay. Yeah. So you remember this? Given you ai greater than or equal to 0 for I belongs to n, I is a natural numbers and I is greater than or equal to 1. Show that 1 plus ai multiplied by 1 plus a1 multiplied by 1 plus a2 multiplied blah 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 until 1 plus ai is greater than or equal to 1 plus a1 plus a2 plus blah 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 until ai, right? Okay, so I will show you this one by the hypothesis that the exercise gives you, right? Okay. We have, this is the solution of the exercise 2. I told you again. Okay. We have 1 plus a1 equal to 1 plus a1. Then from this you get 1 plus a1. Yeah. Is what? Greater than or equal to 1 plus a1. Yeah. And this is, you can say true for I equal to 1. Yeah. And as before, we will suppose that it is true for I equal to n, and then we will show that it is true for I equal to n plus 1, and so this is true for all I belong to integer. Okay. So suppose that it is true, yeah, for I equal to n. It means that 1 plus a1 multiplied by 1 plus a2 multiplied blah blah until 1 plus a n is greater than or equal to 1 plus a1 plus a2 plus blah 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 until an. Yeah. This is true. We suppose that it is true for I equal to n. It means that this is true. 1 plus a1 multiplied by 1 plus a2 multiplied by 1 plus an is greater than or equal to 1 plus a1 plus a2 until an. This is true. And we will show you that it is true for I equal to n plus 1 also, right? So now we have also one plus a1 multiplied by 1 plus a2 multiplied blah blah until an multiplied by 1 plus an plus 1. We have also this one. This one, and now because of what? Because of this 1 plus a1 multiplied by 1 plus a2 multiply until 1 plus an is greater than or equal to this one. I can get from this so this I can get equal to what? Equal to 1 plus a1 plus a2 plus blah 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 until an. Multiplied by 1 plus an plus 1. Why do I get like this? Because you see this 1 plus a1 1 plus a2 multiply until 1 plus an here is greater than or equal to 1 plus a1 plus a2 plus until an, right? So I just replace this expression by this one. So you get this. I get this expression is greater than or equal to this expression, right? And now I just multiply this expression by this equation. I mean, I expand it, right? So I get this one equal to what? Equal to 1 plus a1 plus a2 until an multiplied by 1. So you get 1 plus a1 plus a2 plus blah blah until an, right? And this I will get an plus 1 multiplied by a1 plus a2. Yeah, can say like this. Yeah, 1 plus a1 plus a2 blah blah until an multiplied by an plus 1. Okay, and this I can say this is greater than or equal to 1, or I can say it's greater than 1. Why this expression greater than 1? 1 plus a1 plus a2 until an is greater than 1. Because by the assumption, by the hypothesis, it is given that ai is greater than or equal to 0. It is a non-negative one. Ai is non-negative one. I mean a1, a2 until an is non-negative. So when we sum up them together, we will get something that is non-negative. And a plus 1, it must be that it is greater than or equal to what? 1, right? And if this is greater than or equal to 1, it's multiplied by an, that is a positive 1. It's also positive, right? So for the whole, for the whole expression, something that I should call here, it is greater than or equal to what? It is greater than or equal to 0. Yeah. And and something that we want here, we just want here is greater than or equal to what? An plus 1, right? Yeah. So this one is greater than or equal to 1, and you multiply it by an plus 1, so it is greater than also an plus 1. Yeah. What I mean that this constant is greater than or equal to 1, and now you multiply it by an plus 1, so you get it must be greater than or equal to an plus 1, right? You just multiply. Suppose this one is x. This expression is x, and now x is greater than or equal to what? This expression, I suppose it should be x, and x is greater than or equal to 1. And now I multiply it by the positive number, I mean a non-negative number here, an plus 1. So an plus 1 multiplied by x is greater than or equal to 1 times an plus 1. So this greater than or equal to an plus 1, right? So from this I get greater than or equal to 1 plus a1 plus a2 plus blah 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 until an, and the last term that I get is an plus 1, right? An plus 1. So something I got here, it means that 1 plus a1 multiplied by 1 plus a2 multiplied blah blah until 1 plus an 1 plus an plus 1 is greater than or equal, yeah, 1 plus a1 plus a2 plus blah 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 until an plus an plus 1 plus 1. And if I got this true, it means that the expression or something that given in the exercise is true for what? For I equal to, yeah, for I equal to n plus 1. It means that it's true, yeah, for I equal to n plus 1. Yeah, and by induction, this is true for all I belong to n. So you can say by induction, it is true for all I belong to natural number. Right. And so 1 plus a 1 plus multiplied by 1 plus a2 blah 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 until 1 plus an, or we can say ai, right, is greater than or equal to 1 plus a1 plus a2 plus until ai. Okay, yeah, this is the answers of what exercise 2. And for the exercise 3, I will review the answer or the solution in the next video. Thank you for your watching. We will meet you in the next video. Please do not to subscribe my YouTube channel. As I told you before, just search my name. Yeah, Paksokret, P-A-K-S-O-K-R-E-T-A. And we'll see some of my video. Yeah, please kindly subscribe my YouTube channel to get a video that I upload in YouTube. Thank you.